It was the great Italian scientist Luigi Galvani who first discovered animal electricity way back in about 1790 or so, when he was experimenting with frogs' legs. And he just happened to have a recently dissected set of frogs' legs sitting on his bench. And he noticed that whenever his machine that generated electrical sparks generated a spark, the frog's legs would twitch if his assistant, his wife in fact, happened to be touching the nerve that supplied the leg with a metal implement. And so his idea was, at the time, that the spark was stimulating the frog's legs to twitch. Galvani knew that lightning is a form of electricity, so he decided to see if the frog's legs would twitch in response to lightning. So he rigged his frog's legs up on the top of his house, and he discovered that, yes, indeed, they did twitch when lightning was around. And he then did the control experiment when there was no lightning about, and he discovered that the frog's legs sometimes also twitched. So he decided that what that meant was that animals had their own intrinsic electricity, and this was what was causing the frog's legs to twitch. It took some time for the science of animal electricity to really get going. But subsequently, electrical signals were recorded from muscle fibres, and one of the things that was really a big stimulus to this was the discovery of electric fishes, where quite clearly humans were getting electrical shocks from fish, and therefore the fish must be generating their own electricity. And so this became another exciting avenue for research. And then in about the 1950s, two British scientists, Hodgkin and Huxley, started to experiment to see if they could measure the electrical signals in nerves. And because they needed a very large nerve, they used the giant axon from the squid. And they were probably the first to record a full-blooded nerve impulse or action potential. And they hypothesized that some ion channels, some tiny pores, must underlie this action potential, but it took a long time to see those because of the difficulties in recording the incredibly tiny currents.